So this is the first video for the Class A addresses. So now I've moved into Class A addressing and giving you some examples of some typical kind of subnetting for each class. So I'm going to start this group of Class A addresses with 2 hosts, and that's as you know from the previous videos, it's called the serial mask or the WAN interface mask. So I'm going to create WAN subnets or 10 branch offices from network address 10.1.1/0. So I'm going to start with a Class A address, and that's what that is. And I only want 2 host addresses because a WAN subnet has 2 routers, and each router has a WAN interface. So there's only 2 host addresses required per that WAN subnet or WAN link. So here's an example. There's the data center there, and I've got 10 branch offices, and each of these have a separate WAN link, therefore a separate WAN subnet. It's just another broadcast domain, and that's currently the topology, hub and spoke. And step 1, I want to calculate the subnet mask for 2 hosts. So that's easy enough. I'll just go, and in this case it is a /30, and you've probably encountered that with some of the other videos where that's what it is. It's a 252. So it's a /30 mask, 6 subnet bits, so that gives me 64 subnets and 2 host bits per subnet. And that gives me 2 hosts. So there it is there. There's the 2 hosts. So that's just the 2 bits that I can use for hosts. And the other 6 bits are for subnets. So the host calculation is easy. It's just the first 2 bits, and that gives me 3 plus the number 0 equals 4 addresses. And I subtract 2 for the network and broadcast, and that's where I only get 2 host addresses that I can assign. And step 2, calculate the number of bits available for subnets. So in this case, this is kind of key too, because there are often a lot of WAN links connecting branch offices, so you want lots of subnets. So I've got 6 subnets available for a maximum of 64 subnets. So think of it as 64 branch offices, and I can connect up 64. I only want 10, so there's lots of room for expansion, for scalability. So that's a good thing to keep in mind. So there's the 2 bits available for hosts and 6 bits available for subnetting. 2 to the 6 is 64, and so each subnet has 2 hosts, and there's room for additional WAN links for other offices and various other things you're doing as well. So that's just very standard network design right there. So you've got 64 subnets I'm going to assign or create from that one Class A address for WAN connections. So it's all has to do with WAN connections for this example. So what's the subnet multiple to assign subnets? Start creating my ranges. Well, in this case, there's my host. So the third bit position 3, what's that? Well, that's a 4 for bit position 3. So there's my multiple. That bit position 3 has a value of 4, so that's my multiple there. And that gives me a lot of subnets, 64 altogether, 0 through 252. So lots of subnets available. And I'm going to calculate my network broadcast and host addresses. The 0 subnet is going to be 10.1.1.0/30. That's my first subnet that I'm going to start with. And there's 2 hosts only, and the multiple is 4 that I'm going to keep in mind to start creating the other subnets. In this case, I just like to show you just how I can change these different numbers if I had wanted to. 10.1.1, I can get 64. If I needed 64 more, I would go with a 10.1.2, and I can derive a bunch of 64 subnets from that. Or I could do 10.2.1 for another 64. So you see how with 10.x addressing, there's so much you can do with them, because there's so many octets available for numbering, within the second and third octet. A lot of different values you can use to create more subnets. So that's something to keep in mind how that works, and it illustrates it quite well here. As you see, I can change any bits that I want if I need to keep adding subnets for a new subnet range, 64 more. I just changed this to a 2, for example, and then I can do the. I could have used that as an example. Here's when I got started with 10.1.2 as well. So that just gives an example of how subnets are expanded, or how the 10 dot address range is so valuable when you've got a larger network, particularly. So there's the 0 subnet, and 10.1.1.0/30, that's 0. Then 1 and 2 are assigned to the host range, and 3 is the broadcast. So pretty quick. And then there's the 4, and then that'll go right through after 4. Then it's going to be 8, 16, or 8, 12, 16, so it's multiples of 4. Then 5 and 6 is going to be the each the host range. That's 10.1.1.5 would go to a local router, and 10.1.1.6 would go to the remote router. Anytime you have a WAN link or any layer 3 link between two devices, you have to have them in the same subnet. You can't have them in different subnets. And 10.1.1.7 is the broadcast address, and it goes right up to 252, and then there's 253 and 254 available for assignment, and 255 is the end of the range, or 10.1.1. And so that's what I would get. I've got a branch office data center. I'm going to assign 10.1.1.1 to that branch office router, and 10.1.1.2 to the data center router. And it'll work quite well, and that's really all there is to it. In this example here, I'm just showing you the all 10 branch offices. There are 10 subnets equals 10 WAN links. I'm showing the 10 subnets for 8, 12, 16, 20, 24, 28, 32, and 36. And so I got up to 36, and that's all I really need to do because there's only 10 offices. And that shows you the network topology and the addresses that you would assign. And a binary numbering example, so 10.1.1.4, I use the 4 subnet for example. So there's 10.1.1.4, and then the host addresses would be 5 and 6, and 7 for the broadcast address.